Hi folks, Mr. Long here. We're going to do a quick screencast on rectilinear motion with algebraic representations, and we're going to be differentiating in this example. Because we're starting out with position, you're being given a position equation, and again it's position, remember it's left and right, it's only moving in one dimension. That's what rectilinear motion is. And we find the acceleration, we want to find the acceleration at time t, where t is 5 pi over 4 seconds. We don't know, these are the AP materials, by the way, that were released in spring 2020. But we also want to know, is the object speeding up or slowing down? And I want you to think about that for a second. An object that is speeding up. So here's an object that's speeding up as I use my, oops, sorry. So it goes slow at the first, and then it goes faster, 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 right? So that means that acceleration and its velocity are in the same direction, right? Because you have to think of acceleration as from F equals ma. Um, so one of Newton's laws. So acceleration really is proportional to the push. So if you're being pushed in the same direction that you're traveling, then you're going to speed up, right? But if you're being pushed in the opposite direction, you're going to slow down. So think of that. If someone pushes you from the back, from your back as you're walking, you're going to go faster. If someone pushes you from the front and you're trying to go forwards, you're going to be slowed down. Okay, it's real simple that way. So if velocity and acceleration are in the opposite directions, which means they have the opposite sign, you're going to be slowing down. Okay, so let's do this. So what's the derivative of 2 tan t? Well, the derivative of tan t is sec squared t. So we have that. Now, I like to write things, some people don't. I like to always write things in terms of sine, cos, and tan. So in particular, sine and cos, really, where possible. No, sine, cos, and tan, I guess. So that's 2 divided by cos squared is that derivative. So since we've got v of t, we might as well go ahead and get what the velocity is at 5 pi over 4. And I drew a little unit circle here to give us to help us remember. This would be a non-calculator question. That's a unit circle there. I've noted where 5 pi over 4 is, and it would be related to here, which is pi by 4. And so we have 2 divided by, I'm replacing t with the ratio, so it's root 2 over 2. Now, it is actually a negative. There should be a negative there, but I think I didn't put that in because I know it's going to be squared anyway. Probably should have put the negative in there, but recognizing that it's going to be squared, you're going to get rid of the negative. So what is root 2 squared? Well, it's just 2. And what is 2 squared? 2 squared is 4. So when we're dividing by a fraction, we multiply by the reciprocal. So since that 2 squared becomes 4, 4 goes here. And since root 2 squared is just 2, the 2 goes there. And then we divide out those 2's. 2 divided by 2 is 1, and I'm left with 4. Okay, so what about acceleration? Acceleration is the derivative of velocity. So what I have to do is differentiate that. So I've rewritten the velocity a little bit differently. I've wrote it with a negative exponent. Now I have 2 choices there. I could have used the quotient rule, or I could have used the chain rule. Doesn't really matter which one you do, to be honest. I prefer the chain rule, but I'm just wondering right now, the quotient rule might have been easier actually. But anyway, it doesn't matter. Either way, you're going to get the same result. So in this case, the inside function is cos t. Set that to u. The outside function is 2u to the negative 2. Okay? And then we differentiate each of those. So I call u the inside function, and then the outside function is, of course, velocity. And then I'm going to have du by dt, negative sine t. And then the derivative of velocity with respect to u is dv by du. Negative 2 times 2 is negative 4. Reduce the exponent by 1 is negative 3. And I have dv by dt is equal to, I have to multiply this together and this together. And that's going to end up being a negative times a negative is a positive. And then I have 4 sine t over cos cubed t. And that's that derivative. Again, pause, rewind, go over that if you need to. So the last thing I need to do is to get what is the acceleration when time is equal to 5 pi over 4. So I'm going to do some calculations here horizontally just to save some space. And again, there's 5 pi over 4 in the unit circle, and there's the root 2 over 2, root 2 over 2 for its related angle of pi by 4. This is the formula we just developed with calculus by differentiating velocity. Now I'm going to replace time with 5 pi over 4 right here. And so as I do that, as I replace that, I'm going to do substitutions. So 5 pi over 4, 5 pi over 4. And if we notice over here, again, it's root 2 over 2. Now this time I did put a negative because I wasn't squaring. And I've got a cube down here, cos cubed. So it's negative root 2 over 2 cubed. And so really a slick little thing here to do that I'm going to take a second to explain. I noticed that I had root 2 over 2 in the top, root 2 over 2 in the bottom. Now, I could have, immediately just wrote, I've gotten rid of this, and then this would have been squared, and that's the most efficient thing to do. But just to help you remember, one of the things that you could have done is broken down this negative root 2 over 2. Oh, by the way, I have a negative over a negative, and this is cubed, so I get rid of the negatives here. Then, so I have root 2 over 2 here, and then what I did is root 2 over 2 times root 2 over 2 squared, which is the same thing as root 2 over 2 cubed. And that way you can see really clearly that root 2 over 2 divided by root 2 over 2 is 1. So again, what do? I've got a fraction here divided by a fraction, so I need to invert and multiply. Okay, so this is gone, that's gone there. Oops. And I'll just put a box around that one. That's gone there as well. So those two are gone. And then what I'm left with is just do the reciprocal of that, which becomes 2 over root 2 squared. And let's see, what is that? 2 squared is 4. Root 2 squared is 2. Okay, and then 4 times 4 is 16. Divided by 2 is 8. All right, so that's my acceleration at 5 pi over 4. So remember, acceleration was 8 here. So the acceleration was 8 at that time, and the velocity was 4. So if the velocity is 4 and the acceleration is 8, it's moving, if we think of positive as to the right, its velocity is 4, positive 4. That means it's moving to the right. And the acceleration is 8. That means being pushed to the right. So if it's being pushed to the right and the velocity is to the right, it has to be speeding up. Okay? So that's it. That's that question. And have yourself a good day.